Hey, Vlad here, devinsideyou.com. Welcome to another video. In the previous video, we have seen how complicated it is sometimes to write tests for streams, and today we're going to hit a brick wall and we'll be forced to revamp our entire design, and we'll actually end up being glad that we had so many tests. We will also make some hard choices about integrating the streams into the rest of our homegrown collections library. Let's get right to it. As always, we're in the Ubuntu virtual machine, which is fully maximized, and we're running Sublime Text inside of it, which is the editor of my choosing. It is also fully maximized. We're using a wonderful plugin called Terminus, which emulates the entire terminal for us, which runs SBT, which we use to rerun the test every time we save the file. We're going to start this video by going to the bottom of the test suite and adding another test. This test is going to be for the filter method, which we don't have yet. So it's going to be a test for filter. Let me scroll down a little bit. Okay, so we're going to have def ascending. In fact, where's the next thing that we have ascending? Let's do this. Let's copy that. Let's go back. Not here. Come on, back to the test like this, right? So this is a typical recursive way to create integers. Okay, so let's say filtered. It's a timeline of int, which is going to be ints filter, take only the even ones, take 5 of them. Okay, and let's do filtered dot forced should be list of 0 to 4 6 8, right? So these are the 5 even numbers. Now obviously we don't have filter yet, so let's go and implement it. Where are we gonna put it? Probably somewhere on map. Where's map? It's over here. All right, so let's go, and in fact, why don't we just go to the foldable factory? Foldable factory, and we have filter over here. So why don't we just take that, and paste it over here like this. So that's going to be a timeline, and that's going to be end. And we could leave it like this, but let's in fact rewrite it like that. Okay, it's a bit more list-like or stream-like. All right, so let's see. It should compile. It's not called element, it's called event. So now it should compile. It's final def, by the way. Final def. There we go. All right, let's create a bit more space here. Why does it take forever to compile? It's just one method. All right, there's an issue with set effect, which means that we probably have forgotten to wrap the entire thing into an environment, which we learned about in the previous episode. Like this. Let's see. Well, that was easy, maybe even too easy. Let's do the same thing for TakeWhile. So let's have a test for TakeWhile. We're creating an environment. Going to have a timeline, which is going to be a timeline of int with an equal sign over here. Let's create some more space like this. Let's have a timeline with a set effect of 1, and we're going to have 6 of them. 1, 2, 3, 4, 5, 6. We don't need this comma over here. So now let's go down here. Let's do format off, copy that, format on. So let's do t1 equals timeline TakeWhile modulo 2. Right, let's take the odd ones in this case. Let's now do t2, and let's take the ones that are less than 3, and let's do, come on, t3, not 4, t3 less than equal 3. Let's do this. All right, so we don't need these like that. All right, so now we have t1, t2, t3. Let's do t1. How did it happen to be g1? Forced should be list of 1. Now it's going to be 1, 2. It's going to be 1, 2, 3. That's 1's going to be 2. That's 1's going to be 3. So we don't have TakeWhile yet. So let's do the same trick. In fact, it's right here. TakeWhile, copy that, go over here, put it down like here, final def. All right, so That's not going to be a timeline. That's going to be event. And over here, we're going to do the same trick. Right, so TakeWhile and filter, they actually look very similar. The only difference is that TakeWhile short circuits over here. Okay, it doesn't touch the ACC. Let's see if I made any mistakes. And it looks like I didn't. I have no idea why it takes forever to compile. It's just one tiny thing. All right, there we go. Okay, so that one was easy as well, but maybe it was too easy, as I already mentioned. One thing that I left out on purpose was a check for how many events occurred. Let's see. So if we add events occurred should be 0, right? So this produces a timeline, right? So this is just essentially like a mapping of a timeline, but it should be it will actually be 1 instead of 0. So this test should fail. So it's going to say 11 was not equal to 0. That's for the one without the memoization. And for this one as well, 11 was not equal to 0. Now, what's happening here is, let's go here. What's happening that it calls fold right, and fold right was the first thing that it does. Like before the whole laziness kicks in, it has to decide whether it's gonna use the first element or not. Now your intuition might be to add an arrow over here, right? To say, oh, we just forgot an arrow. Let's see what's going to happen. It didn't help. So it still says 11 was not equal to 0 in both of them, right? But filter really needs to be lazy, right? Because, the timeline, they gave us a promise that unless we call, head or force or equals, that it will remain lazy. In fact, if you recall in the video about for comprehensions, we had a method called with filter, which the for comprehension actually is calling. And the reason for it was so that the regular collections, they behave a little bit like streams, because filtering is such a common thing, right? Because usually after filtering you do something else with the collection, so you don't want to create this intermediate collection, right? So in the foldable factory, we actually have a method called with_filter, right, which creates this wrapper, which we're going to talk about a bit later. But maybe already we should create a with_filter. Actually, let's go and create with_filter. Filter like this, and what it should do is should just delegate to a filter. And in fact, we're gonna revert that. Okay. Now, for regular collections, we use this wrapper technique, and in fact, today we're going to end up doing something very similar. In fact, we had not only this one case was the with_filter, we actually had yet another case where we had a very similar technique, right? So over here, what we did was we implemented with_filter in such a way that we just created a wrapper that would capture the current foldable factory and this predicate, and then so this wrapper is down over here. Then in for each, it will just insert this predicate, right? So it overrode for each map and flat map, right? And it just injected this predicate in there. So we're going to do something similar. And in fact, another one, a similar situation happened in the video about monads, where we had the IO monad, right? So we have the IO monad over here, and I told you when we were implementing the monad. In fact, let me switch to compiling real quick, maybe even with the test. I told you that if you're not used to this kind of style, was a lot of parametric polymorphism in here. All you need to do is just to follow up the types and to do some sort of type Tetris. But in fact, for I/O, it didn't really work. So if I duplicate that, if I go down over here, if I call this flat map 2, if we just follow the types, then we would do this. We would say, okay, so we have a function AIOB that needs an A. So how we're going to get the A? Well, we do it like this, unsafe run, like this. So now we have the A. So now we can get the IO of B by calling AI of B by passing in an A. What do we need to produce from this function? Well, we just need to produce an IO of B. So we can just return it, right? So this implementation is not the same one as was this one, right? It's not exactly the same. And in fact, it behaves completely differently. So if I make this one the 2 and this one the 0, then probably even more tests will fail. In fact, we're probably not using flat map anywhere, so maybe the tests are not going to fail. I don't believe that we're using flat map somewhere, but basically what will happen here is that this will be initialized, right? So this will be a leak of initialization, right? So what did we do? Well, we did the same thing with a wrapper, right? We just wrapped the whole thing into another IO. We ran this IOB and then returned whatever that returned. And you can do this. You could do the same trick with map. Actually, hold up. Let me do this, right? So we have map. So if you have map 2 over here, and if you just blindly, follow the types, then you're going to have the same thing, unsafe run, okay? Then you're going to have val B equals AB of A, and then you're just going to return the B. This is the B, but we need to return IO of B. So we're doing IO of pure of B. But all of that stuff that already happened, right? It already happened before IO pure. So we were forced to wrap the entire thing in IO pure. And we're going to do the same, a similar trick for our timelines. Let me remove that nonsense. All right, let's do this. So what are we doing here? We're running the test. We don't need to run the test. We actually want to just go back to compiling. In fact, we're going to go back to just compiling the production code and not the test code. All right, so what are we going to do? Well, in just a few seconds, we're going to go to our timeline and rename the timeline everywhere where it says timeline. We're going to rename it to data. And then we're going to create the actual timeline. We're going to put data completely inside of it. So we're going to wrap the timeline inside of yet another timeline, which is going to be called data now. It's probably very, very confusing, so I'm just going to do it, and then you're gonna understand what's happening. So let me close the io.scala. So let me go to timeline. I'll make sure that I have the case sensitivity on here. Okay, so let's go up. Let's go everywhere it says timeline. I'm just going to say data, and everywhere where it says small timeline like this, I'm also going to say data. Now this should compile, right? Because we're not using it anywhere except for the playground. Let's go to playground and playground. Let's just comment it out completely. Okay, so our tests obviously don't compile, but we're not even trying to compile them right now. So the next thing that we're going to do is I'm going to collapse that, and I'm going to collapse that. I'm going to make both of them private, and we're going to put both of them into an object called timeline, like this, right? So this whole thing like that is now inside of timeline. And what we're going to have is we're going to have a class timeline, right? So it's just going to be a final class timeline of plus event. It's going to be a private constructor with a private val, which is just a data over here, which is going to be an IO of data of event. And the constructor is private so that we can have a factory method. In fact, hold up. Let's see, let's do it like that. Okay, let's also import data. Let's do import timeline.data like this. All right, so what we can do now is we can go over here and into the companion object. Let's collapse that real quick like this. All right, so what we're going to do here is we're going to say final private def apply event. We did the similar thing with the set when we integrated trees. So if we go to set, we have a set is just something that is backed by a tree, and then at the very bottom we have the apply method over here that is also private, and you just give it a tree and it creates a set. So we're doing the same thing over here. Okay, so we have the data over here. It's going to be IO of data of event, and it will create a timeline event. Let's actually create more space. We're gonna spend quite a bit of time over here. In fact, let's also remove the one on the left. Oh shit, I removed the one on the bottom. Okay, hold up like this, and let's put it down there. There we go. Okay, we go to timeline. Okay, so we're gonna spend quite a bit of time over here. All right, so where were we over here? So we need to create a timeline event. So we're just doing new timeline, and what we can do is we can actually memorize it the same way as we did before in the non-empty case of data. Now the rest of the things that we're going to do is going to be very, very tedious. We're basically going to copy everything from data back to timeline and just fix the types from data to timeline. So for example, we're going to take the force over here. We actually don't need it in there anymore. We're gonna this one we actually can cut it out. We can cut it out, and we're going to paste it over here. Right, so this is the one that we need for flatten to work. Let's see if it compiles. It should compile because we don't use it anywhere. Let's scroll down a little bit, and I want to take the factories. For some reason I want to have them. So we have a bunch of these factories that start over here. Let's take all of them. All of them. These are already arbitrary, so let's take all of them. Let's go up again. Let's go up and paste them all over here. Okay, so what we're going to do now is we're going to go through all of them, which is going to be a little bit tedious, but sometimes you got to do what you got to do. So we're gonna fix the types, right? So it's not gonna produce a data of event, it's gonna produce a timeline of event, okay? And instead of having this implementation, we're just gonna create a new timeline, right? Basically by calling this apply method, we're gonna create a new timeline, And in here, where we just need to pass it an IO of data. So we're going to say IO pure, and we're going to give it the data, and the data is going to be like this. Okay, the data is just going to be, we're just going to call the same apply method for the data, right? So we're just going to say it's going to be the recent event, and I'm going to actually do this. Recent event equals recent event, and following events equals following events with adapted var args, like this, like that. Okay, and maybe we should save some space, like this, and like that, and let's have it over here like this. In fact, maybe this whole thing is going to fit into one line. Yeah, maybe like that. Okay, so now we're going to do the same thing with the others. For example, this apply, all it needs to do is just needs to call timeline with IO pure data first, like this. Okay, I'm not saving the file, but basically we're going to copy that. Let me do this like that. Yes, let's mark all of them. That's too much, like this. All right, so I'm going to go right, I'm going to go bottom, I'm going to remove the line, I'm going to paste the line. All right, so data event is going to become over here. Data event is going to become timeline event. Okay, that's timeline event. And over here, we're going to have first, second. Over here, we're going to have first, second, third. I'm just delegating everything. First, second, third, fourth. First, second, third, fourth. Not this one. Fourth, fifth. Right, we could have done like the same thing. We could have, delegated to each other, and they would delegate to data IO. But I want to have like only one level of delegation. So I'm going to have first. In fact, in the preparation for this video, I was doing I was trying all the different kinds with delegation and whatnot, and I ended up with an implementation that actually didn't always work. And so I realized that I'm just going to delegate everything and just not worry about it. In fact, even my current script, it is prepared to show you something that it's not going to work because we did not delegate something. Instead of, we try to be smart, but I'm actually improvising a little bit right now, and we're not going to do this. We're just going to skip the whole part. So we're just going to delegate everything. Okay, that's too much to type. So let's do this data, and somewhere here, that's 8th, and that's 9th. And this is going to be the last one over here. I'm just going to copy this whole thing, copy that whole thing, and 9th, comma, following events, command following events, and adapting the var args. Let's see if I made any typos somewhere. Of course I did. A bunch of them. Oh, only one. Cool. Oh yeah, it calls a different apply because I forgot the 10th. Man, so close. One tiny error. All right, now let's go down. So in case you haven't realized, we're doing the companion object first. So this whole arbitrary stuff, data doesn't need it. So we're just going to cut it out, and we're going to go to the timeline companion object somewhere at the, in fact, I don't want to scroll down to the bottom. I'm going to add it over here. No, it's not going to make sense. It's just going to look weird. All right, so over here, before we are going to data, so we're just going to paste it over here, and we probably just need to go to data and rename it to timeline. Timeline, like this. And it's probably not going to work because of timeline end. That should be the only issue. Yes, so we can go into somewhere here, probably here. Let's go over here and say final val, and it's going to be a timeline of nothing, which is going to be a timeline of IO pure of data dot end, right? So again, just simply delegating. All right, what does it say? All right, reference to end is ambiguous. It is both define an object timeline and imported subsequently by import data. I actually didn't want to import data. Where are we importing data? Hold on, import data like this. Okay, so what we're going to do is we're going to remove that. We're we're going to go to everywhere where we say case and we're going to say, man, that's actually kind of tedious. Case and. So instead of case and, we're going to say case data dot and. Let's also do it over here, data dot. And that's fine. Let's seed. Or pattern matching somewhere else. Here, ACC, that's fine. That's fine. That's not fine. Data dot. Here as well. Data dot. Maybe it's fine now. Let's see. All right, some things are still not fine. 18. Wow. Okay. Oh yeah, the same thing happens with not empty. Okay, so case non-empty. All right, so let's go over here. Let's say data. Actually, hold on. Let me do it again, like this, like that. Data dot. Okay, let's see. All right, only 9. Okay, 283. Okay, so we have data over here, data dot. Let's see. Okay, 272. Okay, and we can probably do this, mark all of them, and do data dot end like this. All right, 268, which is over here, and data dot end. All right, and 231. 231, it's over here, data dot. All right. Okay, that's 179, and that should also be a data dot. All right, cool. So let me see at the arbitrary. Maybe I replaced something too much. No. So over here we're seeing timeline end, and over there we're seeing data everywhere. Right. So the next thing that we're going to do is we're going to have the apply method for non-empty. So we don't have the case class non-empty anymore, right? But we still want to be able to create non-empties. So over here we have the val and over here we're going to have an object non-empty. Object non-empty like this, and it's going to have an apply for event. And it's going to take the recent events, which is IO of event, and it's going to have the previous events, which is an IO of timeline of event, and it's going to return the timeline of event, and we're just going to create a new timeline, right? We're delegating everything, right? So we can just say previous events, map, timeline, like this, and over here we're going to create a data non-empty. Right, we're going to say recent event equals recent event, and previous events equals timeline dot data. Let me scroll down a little bit. Let's see if I made any typos. Oh, it looks good. All right. Now we don't have any tests for pattern matching yet, but we're also gonna add a pattern matcher over here and extract a method on apply event, capital event. Come on, capital event like this. It's going to be a timeline. Timeline of event produces an option of a tuple of IO of event, and IO like this, IO of timeline of event like this, and it equals to timeline dot data dot unsafe run match. Okay, so basically we're delegating everything, right? So case data dot end, then it's going to be none. None was a small o, otherwise case not empty, and we're going to have recent event. Let's not forget data dot recent event, and we're going to have previous. Whoops, what happened? Recent event, comma previous events, right? Like this. Then it's going to be a sum of recent event, IO pure of timeline of previous events, like this. Okay, just pattern matching, just delegating. Let's see if I made any typos. All right, what else do we have in the companion object? Okay, hold on. Let's see, data, object data, which is over here. Okay, so we have that. Basically, we have that. We have the and. Oh, okay, timeline ops. Okay, so let's just copy that. Let's go to the object timeline. All right, so we have all of the applies in the end, and let's add it over here. Okay, so now we can just go and Oh, by the way, it was already called timeline. Hold up, let's go down. It should be now called data ops. Data. Okay, so let's go to timeline ops from HTC. All right, so we need to go and say, so this is not data, this is timeline, and timeline. Yeah, and these guys, this data is, hold up, this data everywhere over here is called also timeline. All right, let's see if it compiles. It doesn't. Fold right is not a member of Homegrown Collections timeline. Okay, so we can go to fold right. We can just copy that, go up. This is going to be the first thing that we're going to add into our class over here, right? It's going to be final def fold right, and all that it's going to do is it is going to go to the data, say unsafe run, call fold right on that, pass in the seed, pass in the function, and this will create a data. All right, so I believe that we don't have anything else in the companion object, so now we can progress with the class itself. So hold up, let's collapse that. Let's collapse that. Let's go to object data. Let's collapse that. All right, let's start with the class. So we have we have data. Okay, so let's start with this thing. Let's do that like this. Let's go up. Let's paste it over here, like this and like that. And all right, that's here, that's here, that's here. All right, so what we're gonna do is we're just gonna say data dot unsafe run, apply index. Let's see. Yep, cool. Now we already have fold right, so why don't we just go and grab the fold left, just this whole thing like this. By the way, it probably should be like this. Fold left and fold right. Yeah. All right, so let's go up. So I'm gonna go over here, paste that, equals data dot unsafe run dot fold left seed and function. All right, the next thing is going to be size. We can leave it there, or we can actually cut it out, but let's leave it there. So by the way, it should have been def size, should have been a final def size. All right, so let's go over here. Let's leave the folds at the top. Okay, so let's paste that, def size, final def size equals data dot unsafe run dot size. All right, let's go back to size. What's the next thing? Okay, so we have the apply. We don't have head and tail. Let's go get head and tail. So that's head. So we have apply. We have head, which is a data dot unsafe run dot head, and not apply unsafe run. All right, so let's go to tail, which is over here. Let's go there. Head, this one. Let's go here. Paste that. It's not data, it's timeline. This one's actually kind of cool because we can create a timeline like this, and then we can go data. Instead of saying unsafe run, we can just simply map it, right? Because data is an IO of data, and timeline needs an IO of data. So we can just map over here. We can just call tail. Let's see. Yep, we actually didn't even need that because it's very, very short. All right, so let's go to the bottom. Let's go to the tail. What's the next thing? Is empty and not empty. Let's just do that. Let's go to the top tail over here, paste these in. Okay, so not empty is the same as over here. Not is empty. This one we can just compare it with was empty, right? Was the val empty? Okay, which is called end. Not okay. We don't have any imports, so I have to do this timeline.end. Okay, like this. Right, so let's go to the bottom one, which is this one. Okay, so fold left, fold right, size. Where's take? Did we have take? Did I miss take? Miss take. All right, I want to do take before we do all the others. Yeah, there we go. Let's move take actually up. let's move take. Let's take it. Let's take the take and put it above for each, somewhere under size, for example. All right, so I want to do this. I want to go up. Do we put it below size or above size? Hold up, size, size, below size. All right, cool. So it's gonna have a timeline. Okay, so all we need to do over here is we need to say timeline data.map take amount like this. All right, super easy. All right, let's go to take. Let's go down. All right, so what do we have under take? Okay, what we have for each and filter. In fact, we had reversed. Yeah, reversed. I'm also gonna move reversed. Hold up. So take and let's put reversed in here. Okay, let's go up and paste it over here. That's gonna be timeline, which is going to be just a timeline of data.map.reversed like this. Okay, super simple. Okay, let's go down to reversed. All right, so what do we have? For each filter was filter and so on. Okay, so let's do for each like that. Let's go to the top of reversed. No, that's not this one, reversed. Yeah, this one. All right, so let's do this, which is going to be data.unsafe_run for each function like this. Let's see if I can do map and flat map without going down. So that's going to be map, and it's going to produce a timeline of result. We don't need this, so that's going to be a timeline of data map to map and with the function. All right, cool. What's the next one? Let's go down. All right. Oh yeah, I skipped actually filter with filter and TakeWhile. Let's take all of them. Let's take all of them, go to the top. All right, so we had for each, and then we had these. And all right, let's see. So that's going to be a timeline. Okay, so that's going to be a timeline of data.map filter predicate like this. That's going to be timeline. In fact, we can actually leave this one like this, right? So it's just going to call this one. TakeWhile is going to be a timeline, so it's just going to be a timeline of data.map TakeWhile predicate like this. Let's see. Time, or where is it? 45 is here. Timeline like this. All right, green, awesome. Okay, let's go to map again. All right, so we have flat map. I believe flat map is actually going to be a little bit funny. Flat map, and the same thing for flatten. Let's copy both of these. Let's go to map to the one at the top. Let's paste it over here. We don't need the implementation. All right, now the problem here is that the function is going to be different, right? So it's going to be the function, whoops, too much. It's going to be the function that produces a timeline over here. We're actually going to fix it by the end of this video. And so the implementation is going to be, let's do that, let's do that. So this is going to be timeline of data.map, and then we're going to have flat map, but now we need to actually adapt the function a little bit. So we're going to create a new function that takes the event, it calls function with the event, and then on that we're going to call data, and on that we're going to call unsafe run like this. Let's see if I made any typos. Over here it should be called view actually. Yeah, and that was probably the only typo. We're going to fix this by the end of this video. So by the end of this video, it's going to look pretty much like map as well. All right, let's go to flatten at the bottom. What comes after flatten? Equals and ToString, and then zip and into leave. All right, so equals. We can copy that probably. All right, let's go to flatten, which is at the top. All right, so we're going to go and have it like that. So if that's a timeline, then we're just going to delegate to this dot data dot unsafe run equals that dot data dot unsafe run, and otherwise we can just return false. One brace is missing somewhere over here. All right, what's the next one? The next one is ToString, I believe. Yes, it's ToString. All right, so let's copy the whole thing, because in this case we can actually we actually can't delegate to this one, because it will contain this data, and then we would need to parse the string and stuff. All right, so let's go to equals at the top and go over here and paste that over here. So we basically just need to go here and say timeline, right? Because we can actually pattern match on the timeline. This thing will actually work. Let's see. All right, so all we need to do is now zip and interleave. That's zip. Let's go to ToString at the top, and we're gonna add interleave, which is gonna produce timeline, right? As always, we're just gonna do timeline, data.map, underscore zip that. I believe I did it right, didn't I? Oh, actually, that's not so simple. We need to go to zip, and we're going to need to that data dot unsafe run like this. So a little bit of unpacking. Okay, so let's do the same thing for interleave. Copy that, go to zip, the one at the top. All right, so we're just going to do this, and we're just going to say interleave like that. Hold up, timeline. I believe we're actually finished. So we can go to playground and we can enable that. And let's see if it compiles. Oh, we forgot drained. Drained. Okay, so drained, which is over here. We can actually copy that. What is it? It's above interleave. Ah, that's why we forgot about it. Interleave, and we're going to go over here. I'm going to have force, which is going to be a list of event. So that's just going to be data.unsafe run, and oops, like this, and we're just going to call forced on it. All right, cool. So now it compiles. We can actually run the playground, run main homegrown collections playground, and it still works. Vladislav. All right, so now let's try to run our tests, which is over here, and let's hope that everything is still green, and it is. Awesome. All right, so the next thing that we're going to do is we're going to try to integrate our timeline into the rest of the Homegrown collections library, and there is a problem with that. If we look at our sets or lists or maps, so we go to set, it extends Foldable factory. If we go to list, it extends Foldable factory. Now, the problem with the Foldable factory is that it has the add method, right? We need to implement the add method. And our timeline, it doesn't have the add method. It has it as an extension method, because we wanted to make sure that when we're calling timeline dot, that the timeline is a by name parameter, right? So for the compiler, these are two different things, and we could actually make it think that they're the same, but it's not worth it. And the second problem with the Foldable factory is that over here, add requires a by name parameter, and in the Foldable factory, it doesn't. Now we could actually do this thing, but again, it's really not worth it to impose this by name parameter on all the add methods, for list sets and so on. On the other hand, Foldable factory extends Foldable, and Foldable is less of a princess, so we actually can extend Foldable. The only thing that we need to adapt are going to be these by name parameters for the fold left and for the fold right. And in this case, we actually will force this on all the others, on the sets and on the list, because I just wanted to integrate it into the Homegrown collection series somehow, right? So we're going to go to element over here, and we're going to say that it's a by name parameter, and we're going to go to this element over here and say that this is a by name parameter as well. In fact, I'm going to copy that, because now all hell is going to break loose. All right, so the first one is actually right here, right? Foldable Scala 12, right? So where we're working with the monoids, the monoids are not prepared for this whole lazy evaluation, this whole delayed evaluation, this whole normal order evaluation, and so we need to adapt this function a little bit. We had the same thing with when we were saying flat map identity, and it wouldn't compile because the element was a by name parameter. So what we need to do here is, instead of this, in fact, I'm going to duplicate the line. So instead of this, we will just need to unwrap it a little bit. Right, so we're going to have ACC current, as we used to do back in the day. So I have monoid of super dot operation, right, which is basically exactly the same code that we just threw out, ACC current. And now, at least in this file, it should be happy, I believe. All right, so Oh, 78, 78 over here. All right, so I have here, whoops, here, come on. I thought I copied that. All right, let's copy that and paste that over here. Let's see. All right, fold left. Now we have to do this unwrapping here as well, right? So I have ACC current, and we're gonna call function with ACC current. All right, cool. 14 errors. That's expected. So let's go first to tree, and we find our fold left, and we're gonna paste that over here, and we're gonna paste that over here. All right, let's do the same thing for, hold up, where is it? 2 errors. That's too little. Set. Okay, so let's go to set, and we're gonna go to fold left, paste it over here, fold right, paste it over here. All right, let's scroll up. Let's map. Let's go to map, fold left. Okay, in this case, it's actually like that and like that because it's pair. All right, list, list, fold left, over here, whoops, over here, and over here, like this. Is that all? Almost. Foldable suite. Oh, okay. I don't remember writing this one. Foldable suite. Ah, okay, interesting. Int. Like this one. Okay. Oh yeah, cool. All right, so now let's go to timeline, which is, I have no idea where it is. Timeline. There it is. Let's close all the others. All right, so now we can go to the top, and we can say that it extends foldable of event with this. Let's maybe do that. Let's see how it's gonna look. All right, so it says, oh, okay, so we already have for each. So if we go to for each, we can just throw it out. In fact, do we want to throw it out? Yeah, we're going to throw it out. And size, we're also going to throw it out. All right, that's it. That was kind of fast. And also because we can go to class data and do the same thing over there as well. We can say that it extends foldable event. We don't really need to, but we can. Foldable with, okay, like this. And we probably need to throw out the size, and we probably need to throw out the for each, like that. Okay, cool. Let's go also to fold left and fold right, because these now are overrides, final override, and this one as well. Final over. We don't need to do this, but I just prefer to do this. All right. Now the cool thing is that we can actually go to flat map. Because flat map, if you remember, it should work with any foldable. So if you go to foldable factory, then you see that flat map actually wants a function that produces a foldable. We couldn't do this before, but now we can. So in fact, over here, if we say, let's actually start with data. Let's go flat map at the bottom. This is the one with the data, right? So if we go here, data, we're going to say foldable, and over here, data, we're going to say foldable. It should just compile, right? And now at the top, flat map, we can say foldable, foldable, and over here we can say foldable. This should still work probably. No, it doesn't work anymore, because now all we need to do is we just need to pass in the function like that. Braces. I believe in this case it actually worked. So I can do this, I can do that, and I can just do view. Oh, it calls actually flatten like this. Okay. I believe in this case we don't even need to pass the view, do we? Like this. Yeah, awesome. All right, so one of the things that we inherited from Foldable is a find. Let's real quick go and add a test for it. So we're going to go to timeline, timeline suite like this. Let me put it here. I'm not going to split the screen anymore because I think it's better like this. This way we have more more space to work with. Okay, so I'm going to go here. I'm going to say test find. In fact, you know what? There's nothing special about this test. I'm just going to copy paste it from my script like this. All right, and there we go. And it's green. Awesome. Now, one of the things that we didn't get around to in all of these videos is to define a monoid for the timeline. In fact, because now I have seen that we had to go to Foldable, not the Foldable suite, to Foldable here, and we had to change aggregated, we might as well go to list and find the monoid over here. Do we have a monoid? Hold up, not case sensitive, like this. Yes, this is our monoid concatenation. So let's copy that. Whoops, that's so small. Okay, let's just take that and let's go to timeline to the all right, to the object somewhere at the bottom. Here, probably here. We have the arbitraries, and over here, let's collapse this one. All right, so we're at the very bottom of the companion object for timeline. So we can go over here, paste it over here. So it's going to be called concatenation, but over here we have to do the same trick as we did in the previous video with arbitraries, which is over here. We need to switch them to these guys. So let's see. So instead of a arbitrary, we're just going to say that this is just an a, and over here we're going to have an implicit arb, which is going to be an arbitrary for IO of a, like this, and it's going to be a monoid for timeline. Is that all of them? Yes, that's all of them. Timeline. Okay, and over here we're going to have a monoid for timeline of A. Over here we have an arbitrary, which is an arbitrary for timeline A. That's correct. That's fine. That's not fine. Okay, and we don't have empty. Do we need empty? Hold up. So we can do this, and I mean timeline.end, but we can also go to end because we kind of used to do this. So let's also do final def small end with some sort of event, and it will produce a timeline of event. But all it will do is it will just do this. Okay, so now if we go to concatenation, we can actually make it look the same as before, right? So it's just an A. Okay, I'm not even sure what's prettier. It doesn't really matter. So the next thing that we're going to do is we're going to have a test for that. I'm going to paste it from my script because it's kind of boring to write them. So we have ascending, we have ints, and we have 0, 1, 2, 3, and because we're taking 4 of these integers, events occurred should be 0. That's nothing new, and all of them aggregated should be 6, right? Because 0 plus 1, 2, and 3 should be 6. Okay, let's see, and it is green. Cool. Now, as I already said, our math library, our monoids are not ready for normal order evaluation. Therefore, I'm going to demonstrate something to you. So we're going to have another test, which is going to start very similarly like this. And we're going to go down over here. That's the environment. That's the test. All right. So what we're going to have is we already have 0, 1, 2. So what we're also going to have is we're going to have 3, 4, 5, 6, which is a timeline of int, which is just ints, filter, hold up, that, right, and take 4 of them, right? So there's going to be 3, 4, 5, and 6. So the next thing that we're going to do is we're going to copy that, going to paste that over here, going to bring it to the left, and it's going to be called 7, 8, 9. Why is 6 afraid of 7? Because 7, 8, 9. So that's going to be a 7. All right, so what we're going to have here is events occurred should be 0, but I'm going to comment it out because it's not going to be 0, right? So I'm going to comment this out. The next thing that we're going to do is we're going to create a nesting. So we're going to create a timeline, which is going to be a timeline of int, and which is going to be a timeline. Timeline. Let me scroll down a little bit. And it's going to be a timeline of, let's side effect this. It's going to be 0, 1, 2. That's going to be 3, 4, 6, and that's going to be 7, 8, 9. Let's not forget the commas, comma here and comma here. So let's have this. Let's go down over here. In fact, this one actually will work, but this one will not, like this. Okay, so now this one actually will still work. Hold up, I'm getting ahead of myself. So let's do a flattened, which is timeline of int. Right, and this is going to be timeline.aggregated, right? Because we have a monoid for aggregating timelines, and aggregating nested timelines, it basically just means flattening them. Okay, so let's see. So let's do flatten.forced should be list of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I have no idea why, but in my script I'm doing flatten forced, and it should be the same thing. Should be like that. All right, let's go here. Let's go here. Whoops. No, stop, like this. All right, let's see. Everything's red. Okay, red. Abort it. Duplicate test name. Hold up. That should be aggregated to like this. Let's see. All right, it's red. Oh, there's a 10. I actually wanted to take 3. Hold up. All right, green. Cool. Now what I want to show you is that the events occurred should be 0 even after we aggregate, right? But in fact, it's not going to be 0. It's going to be some really gigantic number because remember the monoids, we built in Scala check into our monoids, so it's going to generate a bunch of them. So if we go to algebraic structure and just ask it not to run any laws, then it should be 3 because we're side effecting over here 3 of them. Right, so the aggregation is not ready for this thing. So let me enable this again, just so that we know this. All right, so I'm just gonna leave it like this. All right, so the test is going to be green now. If I comment this out like this, cool. Now let me show you something that scared the hell out of me when I was preparing the script for this video. For some reason over here, I didn't write it like this. I wrote it like this, less than 6 for some reason, right? And then if I'm right, then we should see a stack overflow. And we do. In fact, that's probably too much to scroll up. Hold up. Okay, I can't really catch it. Okay, it doesn't really matter. Essentially, there is a stack overflow. And I want you to learn from my mistakes, so we're going to reproduce exactly what I did. The first thing that I did is I removed the second filter because I thought that maybe there's some initialization leak. So I replaced that with, okay, n comes in and it's going to be here, and should be smaller or equal than 6. But that didn't really help. I have no idea how I came up with this, but you know, probably because of my experience. Like when every time you see numbers like this, you know, my brain jumped to a hunch about an off by 1 error. And for some reason, I went over here and I put a 7 in here. And for some reason, that thing worked. And so my next thing was try to do this with some big number, and it also worked. Right, and then the next thing that I tried was going to the filter over here again and trying with a 7. Right, so in this case it's just like that. It's just like that. So at least there was nothing fundamental wrong. Okay, so that also worked and should probably work with 20 as well. But for some reason it worked was a 7, right? So the 7 was the first thing that worked. So what happens is that there's an issue with take. You know, we haven't touched take for 2 videos now, I believe, and there is a tiny bug in there. So if you go to a timeline and look at our take over here, then we're going to see that it makes a decision over here that it needs to run again, okay? But in the very end, when it realizes that it's at the very end, then it just returns whatever it calculated. So over here, if this was the last iteration, basically, not the last iteration, the previous to last iteration, then it would calculate the result, this one, which it will return in the last iteration. So it will call loop just in order to return this. And this is exactly what we don't want. So basically we want to recognize that we're almost done. So we're just going to add an else if here, and we're going to say if count plus 1 is going to be the amount, right? So if this should be the last iteration, then just return this thing already, right? Instead of calling loop, right? Like this. And this thing actually fixes that. It took me forever to figure this out, but basically this thing fixes it, okay? So now it's like this, and now I can actually remove that, okay? And then we can go to timeline and do a teeny bit of refactoring. So we have this thing twice, and we have this thing twice, okay? So we can go over here, we can say val next count. In fact, it can be actually a lazy val over here. It's going to be count plus 1. So now over here we can say next count, And over here, I'm going to say lazy val next ACC equals that thing, like that. And let's go and put it over here. Okay, so if the next count is already amount, then just return the next ACC. Otherwise, you know, keep looping, right? And in list, we have the same thing, but for list, it doesn't really matter, right? For list, it doesn't really matter if we run one extra iteration or not. Now, we're pretty much done with this video, but I want to show you some really cool thing that I like to do with streams. In fact, I like it only to do it only with my implementation, because with the Scala streams, it doesn't really work. So what I like to do is I'm going to go over here. And hold up, this one should still be 0, right? I commented out accidentally. Yeah, that's fine. All right. So what I like to do is reducing. So reducing booleans. So it happens very often that you have an if expression where which is compound from like 3 different expressions, right? You say this is true and this is true and this is true, or the same thing was an or. And then you have this chain. So let me show you what I mean. So if you have an environment with a lazy val a, which is a boolean, right? Boolean. It's going to be a side effect of true. And then we're going to have BC, true, false, false. All right. Now what we're going to have here is format off, and format on. And over here, we're going to say A, or, and because you have many of them, you're just going to put all of them in a separate line. So you're going to have A or, B or, C, and this whole thing should be true. Okay. Now the problem that I have with this is that you have no idea how often it happens that you accidentally forget this, and it will compile. It will compile, but the behavior is obviously going to be different, right? So it's still gonna, you know, the test is going to fail, right? But actually, I've forgotten this. Events occurred should be 1. Now what you can do with streams is let's copy that. Let's paste it over here. Right, so let's call it reduce 2, and we're going to have the same things. So we have lazy val ABC, right, like this. So what you can do is you can put them all in a timeline of booleans equals timeline of, and you're going to do the same thing, A, B, C. And the cool thing is that if you forget comma over here, then it's not going to compile, right? This is a compilation error. You can't just have A and then B over there, right? So this is a bit safe, and this is also why I really like it. So what you can do now is you can go and say timeline dot fold left false, right, underscore or should be true, and events occurred. Come on, events occurred should be 1. Like this. Now, if you look at this, this is actually a monoid, right? So this is actually a monoid for booleans. We implemented this in the video for monoids. So if we do aggregated, okay, and we have boolean addition, which is defined over here in the package. So we have boolean addition, which is the boolean addition monoid. Right, so this is the operation and the default is false. It's the same thing. This is the operation and the default is false. So we have the Boolean addition over here. Now it should be true, like this. But in fact, it might leak initializations. In fact, I'm not really sure about this. Hold on. So let's do reset, and yes, and let's do here should be 1. Maybe in this one it's actually in this case it actually might be okay, but no, it's not. No, it's actually 2. All right, so that doesn't really matter. All right, like this one. Okay, now we're going to do the same thing with the list, and hold up, like this with the lists, like that. That's going to be 3, and that's going to be a list. Hold on, list, and that's going to be list, and that's going to be list. That's also going to be list. Okay, so I believe that it should fail because of this, right? So if I comment this out, then it should pass. right? So the problem is that you know the way the list works, everything is evaluated eagerly anyway. But in case of timelines, you know, if you do this with a lazy list, in fact, I didn't try with a lazy list. I tried with the streams in Scala 12. But I believe that if you do it with a lazy list, because there's no var args for binary parameters, this thing will leak initializations, right? So it will run A and B and C even though they're lazy vals, and you don't want that. You want the booleans to short circuit was this thing. There's a reason why I called it reduce. For quite a while now, I've been meaning to squeeze the reduce function into our homegrown collection series, but I could never find time. So reduce is very similar to fold left, but it can only be implemented with ordered collections, because basically what it does is it uses the first element as the seed, and therefore the also the result type of the entire fold is a bit more constrained. So let's just define it real quick. So if you go to list and we find our fold left. Okay, so let's see, we have fold left and we have fold right. Let's just go under both of them. Okay, so we have final def reduce left. In fact, I want to see the fold left as well. Okay, so I'm going to have reduce. In fact, I'm going to copy this thing. So I'm going to do this. I'm going to do that. Okay, so I'm going to call it reduce left. Now, because it's going to use the first element as the seed, it's not going to get the seed in here, and also the result type is going to be constrained. Oops, over here, it's going to be constrained to be some super type of element. Okay, like this. So the implementation is super simple. All we need to do is, okay, we already have the equal sign. All we need to do is we need to take the head, and it returns an option. So we're going to map it, and this is going to be the seed, right? So if there's a head, there's going to be a seed, and we're going to do tail, oh come on, tail dot fold left result, and as I said, you know, the head basically becomes a seed, and we're going to pass in the function. Okay, let's see, because we're returning an option. I forgot to change this to an option. In fact, this is different than in the Scala standard collection library. It doesn't. All right, there we go. So in the Scala standard collection library, if you call reduce left, it will actually throw an exception. There's another one called reduce left option, I believe, and this one behaves exactly like this one. So in fact, what we're going to do is I'm going to copy that. I'm going to do it the other way around. I'm going to do reduce left or throw exception, and this one is just going to return result, and the implementation is just going to be calling reduce left with the same function and then just calling get on it, right? So it's just gonna, you know, if it's not there, then it's just gonna throw an exception. Then we're going to do the same thing with reduce right. So I'm gonna copy this like that. Okay, so it's not an override anymore. It's gonna be reduce right. It's going to be constrained to be a super type of element, and it's going to return an option. The implementation is going to be the same. We're just going to call fold right instead of fold left. Fold right, let's see. And there we go. So let's copy that, paste it over here, and say that it's going to be or throw exception. It's not going to be an option of result, it's just going to be result. Right, so we're just going to do the same thing as over here, just call reduce right, like that. What did I do wrong? Oh yeah, we forgot to remove the seed. Hold up, like that. There we go. That should be it. All right, cool. So now let's take them and let's go to timeline like this. Let's go up. Fold left, fold right. Let's just kind of throw them in over here like this. So everywhere we say element, we're just going to see event. Let's see if that already compiles. I'm not sure. Yeah, it does. Cool. So what we can do now is we can go to our timeline suite, and this is exactly why I called it reduce, because what you can actually do in this case is you can go over here and say timeline reduce left, and instead of passing the false, you just do this, right? So now it should be sum of true, or if you do reduce left or throw an exception. And by the way, there is a reason why I called it with such a long name, because I don't want people to call it, you know, I want people to call the functions that return some type safe result. Okay, so in this case it should be true. Okay, and let's do the same thing for lists over here. Right, let's go list like that. And awesome. All right, we're almost done, really, in this case. So we just need to add a few more tests for the unapplies, right? Because remember, in our timeline, we have a case class not empty for data, but we don't have it for the timeline. Instead, we have the unapply function over here, right? So we're just gonna have a test for it. So we're just gonna have a test for unapply 1, and it's gonna be new environment, and we're going to say 0, 1, 2 should match pattern, which is a Scala testing. So we're going to go over here, we're going to say format off, and we're going to go over here and we're going to say case timeline dot not empty with recent event and previous events. And we're also going to have a guard over here. Also, I don't want to forget the format on. We're just going to have a guard here for fun. So if we have the recent event unsafe run, should be equal to 0, and the previous events unsafe run dot head should be some 1. Then in this case, it should match. And let's also do it like that. Okay, like this maybe, like that. I don't know. Let's see. Let's also do the same one, but without this guard, without the guard. So just like that. Okay, like this. In fact, in this case, we don't need the format on, format off, and we're only doing this just to make sure that there are no side effects. Okay, so events occurred should be 0. Like this. Now, one of the things that we have never actually done, we have never actually implemented unapply seek. So what I'm going to do is I'm going to copy that because I believe in this case it's actually a good occasion. So we're going to have should match pattern, and this should match this pattern, timeline 0, 1, and 2, and events occurred should be 3, obviously. Now it's not going to match. It's not going to match because it doesn't have a valid unapply or unapply seek with method. So what we're going to do is we're going to go and define it. So define it. So we have unapply for non-empty. But if we collapse non-empty, maybe right underneath we can define the other unapply. Let me open it again, because it's going to look very similar, and I want you to see both of them. So it's going to be unapply sequence with event, and we're going to have a timeline comes in, which is a timeline of event, and now it needs to produce an option of seek, right? Seek, which comes from Scala. We don't have it, so I'm going to say Scala dot seek. So we don't have it, but I'm still going to do it like this so that it's perfectly clear. So now I'm going to say this is a very typical thing to do. If it's null, then just none, and otherwise it's just going to be a sum of timeline fold right, and now we're going to use a lazy list. Lazy list is also a sequence from the Scala standard library, and over here we're going to say Scala dot lazy list dot empty, and we're just going to use the same thing, right? Because we use exactly the same operator. And let's close the sum as well. In fact, maybe let's do that like this. It's more visible then. All right, something is missing. There's a brace here for some reason. There we go. All right, and now it's green. And now let's also do the same thing for lists. Let's copy that. Let's go to list. Let's go somewhere at the bottom. What do we have? Non-empty, empty. Yeah, let's put it over here where we have the apply, we have the unapply. And now that's not okay. First of all, okay, that's a list, and that's also going to be a list. Okay, so this list is ours. So it's going to be list, and that's going to be list, and that's going to be list. That's also going to be list, and that's going to be like that. I believe that's it, isn't it? Yeah. All right, so all we need to do is we need to have a tiny test for that. I'm going to copy paste that. So we're going to go to list suite, and we're going to go to the bottom, just paste that test, whatever, it didn't really copy it. Hold up, copy, and paste like this. So list 0, 1, 2 should match case list, right? So remember, these are our lists, right? So if we go over here and remove this and apply, it shouldn't work, okay? And yes, it doesn't work. In fact, it doesn't even compile. Okay, awesome. All right, so I know that it got a bit random towards the end, but we're done. So all we need to do is we need to commit that. Let's click this, commit -am. It's going to be video 32, and I'm going to call it streams. I'm just going to call it filter like this. There will be only 2 more videos about streams. All right, so I already have my key unlocked, and it is being pushed. And let's go see what we did. 50 commits. It says 49, but it's actually already 50. So I'm going to go to filter. All right, let's see what we did. We went to Foldable and we added the by name arrow. We changed the fold left and fold right in Foldable. Okay, so these are fold left related changes. We added reduce left, reduce right. Added the unapply seek. Okay, these are just the arrows for fold left and fold right. Okay, so this is just a big div because we basically moved the whole data thing, right? So we created this whole data, so it's kind of hard to see everything that we did there. Let's scroll down. Where's the next file? Yeah, so this is basically the change. We added a bunch of delegations to data. I shouldn't have clicked on that. Okay, so we have tree where we just have the by name arrows, foldable suite, by name arrows, list suite, just edit the unapply. We have the filter, reduce tests, and there we go. All right, so as I already said, it got a bit weird towards the end. It got a bit random towards the end. It's going to be only 2 more videos about streams in this Homegrown collection series, and then it's going to be actually over, and then let's see what's going to come next. All right, that's all I got for you today. As always, it's been Vlad, devinsider.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you. If you find my videos valuable, consider supporting me on Patreon, but most importantly, take care.